Hi, so in this last few minutes of the discussion, we'll be talking about diffusion and effusion. Now, both of these concepts talk about the movement of gas particles or fluid particles, actually. But the difference is that diffusion is the migration of molecules as a result of random molecular motion. So here we've got two gases, different gases separated in different chambers. Now, this partition, pag ni-remove yan, magmi-mix yan siya, di ba? Because gases can form homogeneous solutions in any proportion. Unreacting gases, as long as they don't react with each other, then they will form homogeneous solution with a different gas or gases at at any proportion at all. So 90-10 na proportion, 50-50 proportion, then it will start to mix. Because property of gases, according to kinetic molecular theory, it gas molecules will move in constant random straight line motion except when they collide with the container walls or with each other. So because of that postulate in kinetic molecular theory, we can assume that the gases would start to mix until they are mixed together in the container because there's nothing stopping them from doing so. Okay? Because the volume of each gas particle is so small compared to the whole volume of the sample, even more compared to the whole volume of the container, that the volume or that the volume of the particle, that specific particle is assumed to be near zero, if not zero. And even if they do collide, sinabi natin kanina, di ba, they will go in a random constant random straight line motion except when they collide. And when they do collide, as long as there's no reaction that occurs, the collision is only fleeting. So sandaling, momentary lang talaga. Sandaling sandali lang with one another and the walls of the container. So then they just bounce off each other. So that's why the gases, we can we can be almost certain that the gases will mix with each other and form a homogeneous solution. Different from effusion yung diffusion kasi yung effusion kailangan, oh, ito pa pala. Here, if you look at the animation, may at one point yung gray particles nasa bottom ng container, right? And then the red particles nasa taas ng container. And then as time passes by, they will mix with each other until may red na sa baba and then may gray na sa taas and then random lang yung motion nila. So that's what diffusion is. In fact, you can even use the power of YouTube to slow down the video to 0.25 na speed and then you can see very clearly na at one point separated sila yung mga different types of gases. I hope you use this silent time to slow down the video, but if not, then that's fine with me as well. Now, let's go to effusion. Sinabi ko different siya sa diffusion, di ba? Kasi, kanina, yung first na condition is that separated sila at first. And with effusion, hindi kailangang separated yung mga gases. It doesn't matter if it's a pure gas or a mixture of gases. As long as empty or may vacuum sa other side, tapos mag-open ka lang ng maliit na part on the partition and then dun lalabas yung gases. Because effusion is the escape of gas molecules from their container through a porous membrane, tiny orifice, or a pinhole. Imagine if um, you stuck a pin on I don't know, a balloon. Pero yung balloon hindi nag-pop. Parang lalabas lang yung air. Diba? Sometimes may sound pa. Sound effects aside, that's effusion. right there. Hindi mo lang makikita yung gases, of course, because air particles are invisible. But if you use colored na gas, yung mga, party tricks ng mga colored gases, then you will see the movement of the gas through that very small butas. Okay, that's effusion right there. Here, we can see effusion in motion. So at the start, nasa loob ng bottle lahat ng green particles, and then it'll slowly travel outside through the small mouth of a bottle. And then it will mix with the gas in the environment outside. Now, both the rate of diffusion and the rate of effusion depends on different factors. For this, we can use as sort of a benchmark or a reference point itong Graham's law here. This is proposed by the chemist Thomas Graham. However, it can be used to describe effusion only for gases at very low pressures. And then the orifice or yung butas must be very tiny. So for only those specific instances. And sometimes sa books, they call this Graham's law of diffusion. However, this law doesn't apply to diffusion. Kasi yung minimeasure lang niya is movement of gases throughout a small orifice. Nadadaan dyan. And that's not diffusion, di ba? That's effusion. Di ba? Diffusion is when you remove a partition in between two different gases and then they start to mix due to random motion of the molecules. So, hindi effective na calculation yung Graham's law when it comes to diffusion. Now, let's look at this gas right here. Let's see. A gas has evolved the fermentation of glucose from the fermentation of glucose. So we have an unknown gas right there. It's found to effuse through a porous barrier in 15 minutes. So my particular amount, let's say 1 mole of a gas. So 1 mole, it took it 15 minutes. So that's for gas. Okay. And then under the same conditions of temperature and pressure, it took an equal amount of nitrogen gas 12 minutes. So 1 mole din at this time, nitrogen gas 12 minutes. Ito yung rate nila. So this is rate of A and then this is rate of the nitrogen gas. Calculate the molar mass of the gas and suggest what the gas might be. Now let's look at our Graham's law here. So rate of effusion of A over rate of effusion of B. When we say rate, that means speed. So my element of time, like miles per hour, kilometers per hour, meters per second. So those are rates or speed. So it took 1 mole 15 minutes, right? And then N2, it took 1 mole 12.0 minutes. So pwede natin gawin is let's just take the time, then i-ratio na lang natin yung time. I-equal natin dito. Square root of the molar mass of nitrogen over the molar mass of whatever unknown gas A is. So that's 15.0 over 12.0 minutes equal to square root of molar mass of N2. That's 2 times 14.01. That's 28.02 grams per mole all over X. So para mawala yung square root, raise both sides to 2. And then you have 15.0 over 12.0 raised to the power of 2, 28.02 over X. Isolate X, 28.02 all over 15 divided by 12 raised to the power of 2. You get this answer right here. That's 17.92. It could be NH3. Now, why do I say that? N is 14.01 plus tatlong 1.008. You get 17.034 and it's very near to 17.92, right? So, pwede siyang NH3. And if you could, uh, if you know other gaseous compounds, the medyo close yung molar mass to what is shown here, then let me know so that meron din ako magamit na examples the next time. Diba? Again, you can look at your reference books for more examples. You can also view the supplementary video playlist. And also, you can look through the reading material again that I posted. I think I think that's it for this session. So I'm scheduled for my booster kasi this week, and I'm a very physically weak person, so I may be down for the week. So if there are delays in answering your messages, please excuse me for this week. Not forever, hopefully. Okay. So I'll be seeing you hopefully when I'm well enough. And that's it for this chapter. I hope you learned something. Goodbye.